Alright, dimethylamine has a Kb of 5.9 times 10 to the negative fourth. We want to figure out the pH of a 25 milliliter sample of that dimethylamine with a 2.05 molar concentration after we put in 25 milliliters of a 1.25 mol. Alright, so very first thing I need to find out is how much of either the base or the strong acid I have left over. So I'm going to do that little lowercase ice table. Well, I'm actually only doing the I and the C to figure out the moles of the dimethylamine and the moles of HCl are in there. So I have 2.05 moles of the base. I have 0.025 liters of that. So I have 0.05125 moles of the base. And the acid, similar thing with the 1.25 molar, I have 0.03125. Alright, so I have excess of the base, so I'm going to subtract out all of the acid from both sides, have it drop to 0. And since I've neutralized all the base, I care about the HB that's being produced, and that's just going to go up by the 0.01325. Alright, so subtraction here, I get 0.0200. Let me make that look better. And this would be 0.03125. Alright, we're going to use those values in just a bit, because now that we know that we have base and the conjugate acid, we're going to worry about an actual good ice table that's using that base and the conjugate acid of that base to create a little bit of hydroxide. Now I'm going to do something here that I'm actually not I'm going to go ahead and write it out. I'm not going to actually end up doing all this math. So what I'm going to do is I'm going to take the moles of that 0.0025, and that would be under 50 milliliters. So that would be my concentration, and the HB would be the 0.03125 over that 50 milliliters. And this is that 1 times 0, 10 to the negative 7th, because it's mostly neutral. And we're expecting the products to go up since we have that neutral water. And I'm not going to write down the E on the base and the HB. I'm only going to write it down for this, because I'm actually not going to do this math with that 0.05. Alright, the reason I'm not, so the Q, let me put it up over here. The Q for a base equation, always kind of the same, but I'm going to write it ever so slightly different. So what I did was I isolated the HB and the B from the normal equation. So and I just how you write it, it didn't really change what we do mathematically. But the reason I did that, I was wanting to point out that this never factors in. And we were always going to end up doing an assumption down here that the X wasn't all that big. So I'm actually going to end up using 0.002 for the base and 0.03125 for the conjugate acid of that base. Not going to worry about the 50 milliliters at all, because they would divide out. They would cancel out when I move it up into this equation. Alright, so I'm kind of doing an assumption here. When I take the Kb that's there, 5.9 times 10 to the negative 4th, that doesn't look like a 9. And I have my HB, 0.03125, and yes, it is moles, but I'm leaving it that way, and the 0.200 as moles as well, and then the OH is just my unknown. Now, it is an approximation. We're assuming the X is so small that that stays 0.002, and this stays 0.03, and we're ignoring that they have that common volume, but this is a safe assumption. So we should be able to get a decent result from this. So 5.9 times 10 to the negative 4th times 0.02 divided by 0.03125 gives me this, which should be my OH concentration. I'll take the negative log of that to get my POH. And since this asks for a pH, I'll do 14 minus that value. And I get a pH, I'll just write it right up here on top, of 10.58.